Hello everyone. Today we are going to solve questions from exercise 8.1 trigonometry chapter for class 10. So let's start with the first question. In triangle ABC, which is right angled at B, AB is 24 centimeter, BC equal to 7 centimeters. We have to determine sin A, cos A, sin C and cos C. So let's see how to solve this question. So in any question, before you start solving, write what is given. So it is given to us that in this triangle, AB is equal to 24 centimeter, BC is equal to 7 centimeter. And what do we have to find? We have to find sin A cos A, and then we have to find sin C cos C. Now for this question, the diagram is not given, friends. So we have to draw that first. So since it's a right angle triangle, let me draw a triangle like this. It's right angled at B. So this is my B. Let me call this A and C. Now AB is given as 24 centimeter. That means this is 24. BC is 7 centimeters. We have to find sin A cos A. So see, this is that angle A and sin C cos C. So this is that angle C. Is that clear, friends? So always remember, for any question in trigonometry, draw the diagram. Even if it is given in the question, copy it again in your paper. Write what is given and write what we have to find. Okay, now let's start the answer. Now you know what is sin A, right? What is sin A, friends? Sin A we know is opposite side upon the hypotenuse. You can just remember O upon H. So you have opposite side upon hypotenuse. Now let's take angle A over here. What is the opposite side for angle A? Yes, it is going to be BC. See? And what is the hypotenuse? It is going to be AC. But the problem is, we don't know what is AC. It is not given to us. So first we need to find what is this AC, and then it will be very easy for us to find the ratios of sine, cos. So how do you find the hypotenuse? That's right, we have to use Pythagoras theorem. Can you tell me what is the theorem? Yes, the hypotenuse square, that is AC square, is nothing but AB square plus BC square. Okay, so this is going to be the Pythagoras theorem. Always write the reasons also that you are using. Okay, so AC square, we don't know, we have to find out. AB square is 24 square, BC square is 7 square. So 24 square is nothing but 576, 7 square is 49. So when you add these two, you will get 625. Okay, AC square is 625. If AC square is 625, what is AC? Square root of 625. So if you find out the square root of 625, it will be 25 centimeters. So this AC over here is nothing but 25 centimeters. So that's it. We have got all the three sides of the triangle. We can easily find out the ratios. So sin A, I had already written over here. It is nothing but BC upon AC. I just need to substitute the value. So BC is going to be 7. And the hypotenuse AC, which I found, is 25. That's it, see. So sin A is 7 by 25. Just write the final answer in a box, friends, so that it's easy to spot. Now I have to find cos A. Can you tell me what is the formula? That's right. It's adjacent side upon hypotenuse. So what is the adjacent side for angle A? Yes, the adjacent side is AB, and the hypotenuse is going to be always the same for a triangle. Whichever angle you take, the hypotenuse for the triangle will be the same. So what is AB over here? 24, and AC is 25. See, that's it. So we have got cos A also. Now let's quickly find sin C cos C. So what do I need to do for this? Right, I have to change my angle here. Now I have to look at sin C. Okay, so sin C, again the formula will be the same, opposite by hypotenuse. But now for angle C, which is the opposite side, yes, AB is going to be the opposite side. Okay, I hope you understood how the opposite side changes. And what is the hypotenuse for C? Of course, it's going to be the same, which is AC. So what is AB? It's 24 and AC is 25. Okay, friends. Now, did you notice one interesting thing? Sin C is 24 by 25 and cos A is 24 by 25. Did you see that? They are both equal. So, it's an interesting observation, and as you proceed further in the chapter, you will come to know why those two ratios are the same. Anyways, let's now find out cos C. Well, cos C is nothing but adjacent upon hypotenuse. Adjacent side for C, yes, it's going to be BC. See, this is BC. The hypotenuse is AC. Now, BC is nothing but 7 and AC is going to be 25. That's it, friends. So we have got all the ratios that they had asked for. I hope you understood this question. The second question says, in figure 8.13, find tan P minus cot R. So this is the figure and we have to find tan P minus cot R. So let's start the answer. So since the diagram is given, let me first draw the diagram. It's a right angle triangle. PQR, it's right angled at Q. This is 13 centimeter PR and this is 12 centimeter. So let us quickly write what is given. What is given to us is that PQ is 12 centimeter, PR is 13 centimeter. What do we have to find? We have to find tan P minus cot R. Okay. So what do we do, friends? For this, again, where is P? Let's locate that. P is over here and R is over here. So what is the definition of tan ratio? Tan P is nothing but, can you tell me? Yes, it's the opposite side divided by the adjacent side. So for angle P, which is the opposite side? Exactly, it is going to be QR. And what is the adjacent side? Yes, it's going to be PQ, right? But however, we don't know what is QR. We are only given PQ and PR. So what we need to now find is what is QR. And can you tell me? I'm sure you must know by now. It is, yes, Pythagoras theorem we are going to use. So PQ square plus QR square is going to be PR square. Again, write the reason as Pythagoras theorem. Okay, now PQ square, what is it? 12 square. QR square, we don't know, we have to find out. PR square is 13 square. So this is 144 plus QR square, 169. So just shift 144 to the other side and we get 25 over here. So QR square is 25. What does that mean? QR has to be equal to 5 centimeters. Okay, so our job is done. We know what is QR. So can we now find out tan P? Definitely. What is tan P? Again, let me write it as QR by PQ. QR is nothing but, yes, it's 5 and PQ, friends, is nothing but 12 centimeters. So tan P is nothing but 5 by 12. Okay, so let me put it in a box. But I'm not done yet because I have to still find out cot R. So let's also find that out. It should be very easy now, friends. Can you tell me what is the definition of cot? Yes, it is the opposite of tan definition. So if tan was opposite upon adjacent, cot will be, yes, adjacent side upon opposite side. So always remember they are both reciprocals of each other. But the problem here is it's not cot of P, it is cot of R. So you have to be very careful. Which angle are they talking about? So it is R. So for R, which is the adjacent side? Yes, it is QR. And for R, what is the opposite side? PQ. Okay, I hope you understood. Just plug in the values now. QR is going to be 5. And what is PQ? Yes, we know it is 12. So cot R is 5 by 12. Did you again notice? Cot R is also 5 by 12. Tan P is also 5 by 12. The same pattern is repeating again. So anyways, let's now see what is tan P minus cot R. So tan P minus cot R is going to be 5 by 12 minus 5 by 12, which is 0. So that is the answer for this question. So friends, maths is all about finding out such patterns, you know. So keep this in mind because as we go later in the chapter, you will know why these two ratios are the same. The third question says, if sine A is 3 by 4, calculate cos A and tan A. So let's solve this. So let's write the data that is given to us. It is given to us that sine A is 3 by 4 and we have to find cos A and tan A, friends. Okay, again, no diagram. Never do trigonometry question without diagram. So let me draw a simple diagram for this. Obviously, it's a right angle triangle. Let me take A conveniently over here, friends. A, B and C. It's right angled at B. Let me consider like that. So sine A is given as 3 by 4. We have to find cos A and tan A. Okay, so friends, again, let's start with the definition of sine A. What is it? It is nothing but the opposite side upon hypotenuse. Now, in the previous questions, we were given the actual length of the sides, but here you are given the ratio itself. You are given that sine A is 3 by 4. Just see how this question is different from the previous two questions. Okay, here you are given the ratio directly. But does it mean that the opposite side is 3 centimeters? No, the opposite side is not 3. The hypotenuse side is also not 4 centimeter, friends. It's just telling the ratio. So something common was cancelled, and that's why the ratio became 3 by 4. So let that common term which was cancelled be k. Okay, always understand that this is just the ratio. It's not the actual length of the sides. Okay, so the actual length of the sides will be 3k and 4k. So sine A means opposite side. So for A, which is the opposite side? Yes, this is the opposite side. So that is 3k. The hypotenuse is given as 4k. Okay, this is clear. We have to find out cos A. Now you know what is the definition of cos A, right? It is nothing but adjacent upon hypotenuse. But the problem is we don't know what is the adjacent side. So our job now is to find the adjacent side. Again, let's use Pythagoras theorem. So AB square plus BC square is equal to AC square. The reason, always write the reason here, Pythagoras theorem. Okay, AB square, I don't know, I have to find out. BC square is 3k, the whole square. Remember friends, it is 3 and k both are being squared, equal to 4k the whole square. Okay, so this is just your square knowledge that will come handy now. So AB square is 16k square minus 9k square. What is that? 7k square. That's right. Okay, but we want AB, right? So it will be square root of 7k square. Now k square is under the square root sign, so it can easily come out. The 7 will be stuck over here only. So it will be k root 7. So this AB over here is k root 7. Is it fine? Now I know what is the adjacent side. I can easily find what is cos A. So cos A is nothing but the adjacent side upon hypotenuse. So for A, what is the adjacent side? AB, and what is the hypotenuse? AC. Okay, so the adjacent side is k root 7. The hypotenuse is 4k, friends. Okay, so k gets cancelled. So cos A is square root of 7 by 4. See, we got one ratio. Is that what we want? Yes, and we want also tan A. So now it should be easy. So tan A, what is the definition? It is nothing but the opposite side upon adjacent side. So for A, what is the opposite side? Yes, 3k. And what is the adjacent side? K root 7. So k gets cancelled. So you get tan A as 3 by root 7, and that's the answer. Now here is the fourth question. Given 15 cot A is 8, you have to find sin A and sec A. Very similar to the third question. So let's do it. So friends, let's write what is given to us. It is given that 15 cot A is 8. And what do we have to find out? We have to find out sin A and sec A. Again, let's draw the diagram because the diagram is not given at all. So I'll take this point as A. So this is my BC and cot A is given. Okay, so let us write the definition of cot A. Can you tell me? Yes, it is going to be the adjacent side upon the opposite side. Now again in this question you are given the ratio directly because it's given 15 cot A is 8. That means what is cot A? Yes, it is 8 by 15. So I can say that this is 8 by 15, which means my adjacent side is 8k and my opposite side is 15k. So if this is angle A, the adjacent side, yes, this is the adjacent side. It is 8k and the opposite side is 15k. Now to find out sin A, I need to know what is the hypotenuse, because what is sin A? Yes, it is O by H, that is opposite upon hypotenuse. So I need to know the hypotenuse. So let's use the Pythagoras theorem. AC square is equal to AB square plus BC square. Okay, so what is that? The hypotenuse, I have no idea what that is, but AB square is 8k the whole square and BC is 15k the whole square. Okay, please write the reason, friends, here. Pythagoras theorem. Okay, so what is 8 square? Of course, it's 64 k square. 15 square, it is 25. So when I add 64 and 225, I'll get 289 k square. Okay, I'll get 289 k square. So that means AC is square root of 289 k square. So the k comes outside. Now 289 is also a perfect square, friends. It's actually 17. Okay, so 17k. So very nicely here you have got the perfect square. So that's nice. So AC is 17k over here. Fine. So now very easily you can find out what is sin A and sec A. So let's use the formula. It is nothing but the opposite side upon hypotenuse. So what is the opposite for A? Yes, 15k. And the hypotenuse we just now found, it is 17k. K and k gets cancelled. So I can say my sin A is 15 by 17. Just put it in the box. Then I need to find sec A. What is the definition of sec A? Yes, it is nothing but hypotenuse divided by the adjacent side. It's just the reciprocal of cos. Okay, so hypotenuse is nothing but 17k. And my adjacent side is 8k. See? Okay, so k and k gets cancelled. I'll get 17 by 8. So sec A is 17 by 8, friends. See? We have easily got the sin A and sec A values. Here is the fifth question. Given sec theta equal to 13 by 12, you have to calculate all other trigonometric ratios. So you have to find all the trigonometric ratios. Only one of them is given to us. So let's start. So let's write the given data. It's given that sec theta is nothing but 13 by 12. And we have to find all the trigonometric ratios, friends. So shall we write all the ratios just so that we don't miss any ratio out? So we have sin theta, cos theta, tan theta, the reciprocal of sine, which is cosec. Reciprocal of cos is already given. Reciprocal of tan is cot theta. Okay, so these are the 5 ratios I need to find. So let's draw the diagram. Here is my theta, and sec theta is given as 13 by 12. Now we know the definition. What is sec theta? Yes, hypotenuse side upon the adjacent side. So you get 13k by 12k. So if this is my theta, which is the hypotenuse? Yes, this is my hypotenuse, and the adjacent is this side. See? It is 12k. So which side do we have to find out? Yes, this side. So once we find this side, we can find out all the ratios. So just for convenience, let me label the vertices over here. So by Pythagoras theorem, AB square plus BC square is equal to AC square. Let me write the reason over here. Pythagoras theorem. So AB square is 12k the whole square. BC square is something we have to find. This is 13k the whole square. So very carefully do the calculations, friends. So you'll get 169k square. So BC square is 169k square minus this term. So I'll get 169 minus 144 is 25. So BC is square root of 25k square. Now 25 is a perfect square, which is great. So you'll get 5k. So BC is 5k over here. So let me write this 5k. That's it, friends. We have all the sides. So let's easily find out all the ratios. So what is sin theta? Opposite side upon hypotenuse. So here for theta, the opposite side is 5k. So when writing down, friends, what is the opposite side? What is the adjacent side? Be very careful. Don't mix up the values. So opposite side is 5k. Hypotenuse is 13k. So sin theta is 5 by 13. See, we have easily got. Now let's find out cos theta. It is nothing but the adjacent side upon hypotenuse. So for theta, this is the adjacent 12k and hypotenuse obviously 13k. So cos theta is 12 by 13. Okay. Now tan theta. Tan theta definition is nothing but opposite upon adjacent. That's right. So for theta, what is the opposite? 5k, and the adjacent is 12k. So tan theta is 5 by 12. Okay. Now alternately, you can also do tan theta as sin theta by cos theta, right? If you recall, this is also the definition of tan theta. So you can also try this way if you find it easy. So sin theta we already found, divided by cos theta is 12 by 13. So just take the reciprocal here. So again, you'll get obviously the same answer. Whichever method you find easy, you can go ahead with that. So now tan theta, I have found out. What is remaining? Yes, cosec theta. So cosec theta, the formula is going to be hypotenuse by opposite sides. So the hypotenuse for theta here, again 13k by 5k. So cosec theta is 13 by 5. Only one is remaining, cot theta. So cot theta is nothing but adjacent upon opposite. So adjacent is 12k, opposite is 5k, friends. So cot theta is 12 by 5. So I hope you understood this. We have found all the ratios. Now here is the sixth question. If angle A and angle B are acute angles such that cos A is equal to cos B, you have to show that angle A is equal to angle B. So let's do this. So again friends, let's see what is given to us. It is given that angle A and angle B. So what is given is that angle A and angle B are acute and cos A is equal to cos B. Okay, this is what is given. What we have to prove is, okay, to prove that angle A is equal to angle B. Now friends, let's start the proof. Now if you see, nowhere is it given that angle A and angle B are angles of the same triangle. So as per the question, it's given that they are two angles. Now there are two ways of doing this. Either you can assume that these two angles belong in the same triangle, in the same right angle triangle, and you can proceed. However, in the NCERT examples, solved examples, they have taken the two angles to be from different triangle, friends. So I'm going to follow that method and I'm going to give the answer for that. Okay. So angle A and angle B are acute. So let me take two different triangles. Okay. I'm going to take two different triangles. Here I have A and here I have B. Okay, these two angles, they are acute, right? So I've made them acute. Now let me mark the other vertices as P, Q, R and S. So these two angles are acute and cos A is equal to cos B. Okay friends, so let's start with always what is given to us. So cos A is equal to cos B. So let's apply the definition of cos. What is cos? Yes, it is adjacent side upon hypotenuse. So for angle A, what is the adjacent side? Yes, it is going to be QA. The hypotenuse is AP, right? And for cos B, the adjacent side is BS and the hypotenuse is BR. Okay, so this is what it means. Now friends, how do we proceed? Okay, so we are going to take the help of similar triangles. Okay, that's what you need to keep in mind. So what we will show is that these two angles are similar, because when two angles are similar, the corresponding angles are always going to be equal. So whenever they try to ask you to prove two angles are equal, always check, can I show that the two triangles are similar? Okay, now I have to show that these two triangles are similar, then my job is done. How do I show that the two triangles are similar? Now with what data is given, you can try to prove that the corresponding sides are in the same ratio. Okay friends, so what I mean by that is, if I somehow prove that QA by BS, see I'm taking the corresponding sides of the two triangles, QA by BS equal to AP by BR. Okay, AP by BR equal to PQ by RS. So if I show this, then I can show that the two triangles are similar. Okay, now with what is given, what I can do is, from equation 1, I can rewrite slightly. So I'll write QA upon this BS, I will bring it down. See, like this. And this AP, I'll bring it up. Okay, that's it. Slight trick I'm using to get the answer. So this is what we have. See, if you observe QA, BS, AP and BR. So actually we have got half of the proof done. We just have to show that this whole thing is equal to PQ by RS also. So what we say is, let QA by BS equal to AP by BR equal to any constant, friends. You can take it as K or P or R, anything. So equal to a constant K. Okay. So what we can say is QA by BS is equal to K. Yes, that's what it means, which means QA is equal to K times BS. Yes, just remember this is K into BS. Okay, let me call this as 2. Also, I can say AP by BR over here is equal to K. See, I'm just using this. So AP is nothing but K times BR. Okay, I hope you understood till here. Now what we do is we'll take the third ratio. See, the third ratio is PQ by RS, friends. Now let's see what is PQ and RS. So PQ is this and RS is this. So how can I connect PQ with the other sides and RS with the other sides? Yes, again I use Pythagoras theorem. So I can say that PQ square plus QA square is equal to AP square by Pythagoras theorem. So I can write PQ square as AP square minus QA square, which means PQ is square root of AP square minus QA square, friends. But just have a look at this. I have just now written AP as KBR and QA as KBS. So why not substitute the values over here? So instead of AP, all I'm doing is write K into BR. That's it. So K into BR, the whole square, minus QA, I'm going to write as K into BS. Okay, this is what we are going to do. Now this will be K square, BR square minus K square, BS square. So now I can take out the K square common from both the terms. And since this is square root of K square, the K can easily come out, friends. So I'll get BR square minus BS square, and all this is equal to PQ, right? But what about the other side, RS? Let's also write RS in terms of Pythagoras theorem. So RS square plus BS square is equal to BR square by Pythagoras theorem. So let me write RS square as BR square minus BS square. Okay, so RS is nothing but square root of BR square minus BS square. So let me call this as 4 and 5. So let's substitute the value of PQ and RS in this ratio, friends. Okay, so I will get PQ by RS equal to, what is PQ? K into square root of BR square minus BS square divided by RS is nothing but square root of BR square minus BS square. Wow, did you see that? These two terms are one and the same. So I can cancel them safely. So PQ by RS is nothing but K. And just see, already this ratio is equal to K. And now we have shown that PQ by RS is also equal to K. Therefore, we can say that QA by BS is equal to AP by BR equal to PQ by RS is equal to K. See, friends, we have shown that the corresponding sides are in the same proportion or ratio. So, therefore, the two triangles, which is triangle PQA, is similar to triangle RSB. Right? So the two triangles are similar. That means the corresponding angles can be equal. So that means angle A is equal to angle B, and hence this is how you have to prove that angle A is equal to angle B. So here is the seventh question. If cot theta is equal to 7 by 8, you have to evaluate these two expressions. So let's start one by one. So let's write what is given to us. So the given data is that cot theta is equal to 7 by 8. This is what is given. We have to find the value of this expression. So let me copy it down. Okay, friends, so first let me draw the diagram as usual. Here is my theta. Now, cot theta is given as 7 by 8. So that is nothing but the adjacent side upon the opposite side. So let me write it as 7k by 8k. So if I label this diagram as ABC, theta is the adjacent side. See, this is 7k and the opposite side is 8k. Now we have to find sine theta and cos theta, friends. Now if you recall, sine theta has hypotenuse, right? And so does cos theta. And we have no idea what the hypotenuse is. So let's find the hypotenuse first using Pythagoras theorem. Okay, so see how step by step we are proceeding. Always start with what is given to you by Pythagoras theorem. Okay, so what is AC square? We don't know. AB is 7k the whole square plus BC is 8k the whole square. This is 49k square, 64k square. Just be careful when adding, friends. This is going to be 13 and 113. So my AC is going to be square root of this. So AC is k into square root of 113. Okay, here unfortunately we didn't get a perfect square, so we'll have to leave it like this. Now let's come back to what we want. We want to find out this value. So let me just copy it. 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta, 1 minus cos theta. Okay, so let us find out, friends, what is sine theta. Sine theta is nothing but the opposite side upon the hypotenuse side, which is the opposite side is 8k and the hypotenuse is, yes, we just found out this as the value. So the sine theta is nothing but 8 by square root of 113. And what is cos theta? It is adjacent divided by hypotenuse. Adjacent side is, yes, 7k and k is square root of 113. So cos theta is 7 by square root of 113. So these are the sine and cos values. Now friends, you can directly substitute this as it is and get the value, but that will be a little bit lengthy. So instead of that, let's try something else. Did you observe that this expression looks like a plus b into a minus b? And also the denominator, a plus b into a minus b. So do you recall which identity it is? Yes, a square minus b square. See, a plus b into a minus b is a square minus b square. So I'm going to use that here. So 1 minus sine square theta I'll get, and denominator I'll get 1 minus cos square theta. So the advantage is, friends, your calculations will be reduced a lot. Okay. Now, let me take it to the other side. Okay, so I'll just rewrite it. Okay, so 1 minus, what is sine theta, friends? Yes, 8 by square root of 113. Don't forget to write this square, okay? Okay, now what is cos theta? 7 by square root of 113. Again, square it. Now you have to do the proper squaring here. 8 square is 64. Square root of 113 means that square root goes off. That's it. Again here 7 square is 49 and 113, friends. So again same old taking the LCM. 113 is the LCM. Okay. Simple calculations, but you need to be careful again. Okay. So this is equal to, now 113 minus 64 is 49. By 113. Now instead of writing again numerator denominator, I'll just put the division sign here. Okay, so this is what I get. Now I take the reciprocal. So yes, so 113 gets cancelled, friends. So we get 49 by 64. So 49 by 64 is the value of this entire expression. Now the second part is to find out what is cot squared theta. It's the same diagram we have to refer to. Only thing is the expression has changed. So this is going to be super easy because they've already given what is cot theta, right? So cot squared theta is nothing but 7 by 8 the whole square, which is 49 by 64. See friends, this is amazing because this whole expression was also equal to 49 by 64 and cot square theta is also equal to 49 by 64. So I think they gave this to you on purpose so that you observe these small patterns, because that will be helpful when you proceed in the chapter. So this is the answer. Now here is the 8th question. If 3 cot A is 4, check whether 1 minus tan square A upon 1 plus tan square A is equal to cos square A minus sin square A or not. So we have to check whether this equality is true or not. So let's check it out. So what is given to us is that 3 cot A equal to 4, and we have to find, what we have to check is that if this expression is equal to the RHS. Let me copy it down. Okay. So again friends, let me draw the diagram so that I get a better idea of what is happening. So if this is my A, let me call this as B and C. So cot A, if 3 cot A is 4, obviously cot A is going to be 4 by 3, which means my adjacent upon opposite is 4 by 3. So let me write it as 4k by 3k. So if this is A, the adjacent is 4k, the opposite is 3k. Now let's again see what we have to find. We have to find tan A, we have to also find cos and sin. So obviously we need to know the hypotenuse. So let's use Pythagoras theorem. AC square is BC square plus AB square. This is by the Pythagoras theorem. So BC square is nothing but 3k the whole square. This is 4k the whole square. So very carefully do the calculations. You will get AC square as 25k square. It's good that you got a perfect square. So you'll get AC as 5k friends. So here it is going to be 5k. So let's quickly find out sin A. Sin A is going to be opposite upon hypotenuse. So for this the opposite is 3k. Hypotenuse is 5k. So 3 by 5 is sin A, and cos A adjacent upon hypotenuse. So it is going to be 4k by 5k, right? Yes. So this is 4k by 5k. And now we have to find out tan A also. So either you can take tan A as sin A by cos A, or you can just apply the other definition. Opposite by adjacent, which is nothing but 3k by 4k. So this is my tan A friends. So all I need to do now is check whether this expression is equal to this part. So whenever you have to show friends, or you have to check if an equation is true, always take it as LHS and RHS. So this is my LHS, this is my RHS. So let me solve the LHS separately and the RHS separately, and if they end up to get the same value, then they are equal. So always go for the LHS RHS approach. Now let me first write what is the LHS. So this is my LHS. Now what is tan square A? So tan A is nothing but 3 by 4. So I just have to simply substitute here the value of tan A. Now this is nothing but 9 by 16. Yes. 1 plus 3 square 9 by 16. Again you need to know your LCM properly. So 16 minus 9 divided by, here it will be 16 plus 9. So 16 minus 9 is 7 divided by, this is going to be 25, right? Okay. So this is, let me take the reciprocal. Yes. So that whole expression, the LHS is 7 by 25 friends. Just keep this in mind. Now let's quickly go to the RHS part. What is the RHS? Cos square A minus sin square A. Now let's substitute. Cos A is 4 by 5 the whole square. Sin A is 3 by 5 the whole square. So this is nothing but 16 by 25, 9 by 25. The LCM is same. The denominator is same. So 16 minus 9, which is 7 by 25. Wow, that's great. So you got the RHS also as 7 by 25. That means LHS is equal to RHS. Therefore, you can clearly say that 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. Okay friends, I hope you understood. Now here is the 9th question. In triangle ABC, right angled at B, if tan A is 1 upon square root of 3, find the value of these expressions. So let's start. So friends, let's write what is given to us. It is given that tan A is 1 upon square root of 3 and the right angle is at B. So if I have my diagram here, the right angle is at B, okay? So that means I can call this as A and this is C. I have to find these values. Let me copy it down. Okay friends, so let's start solving. Tan A is 1 by root 3, which is nothing but the opposite side upon adjacent side. So I can write it as K upon K root 3, right? So here is my angle A. Now friends, be very careful because I have taken angle A at the top. So what will be the opposite side? Yes, this will be the opposite side, BC. So this is my K and my adjacent side over here will be K square root of 3. Okay. Again, I need to know what is the hypotenuse because I want sine and cos, right? So let's find out the hypotenuse using Pythagoras theorem. So let me write it down. Pythagoras theorem. So AC square is AB is going to be K root 3 the whole square plus K square. So this is K square into 3 plus K square. Now little bit of algebra, just take care. So K square, you will get K square. Here you have 1, right? So 3 plus 1 is 4K square. So AC, it will be 2K friends. Okay, I hope you understood this. So this is going to be 2K. Now that I know my hypotenuse, can I easily find my sine? It's not sine theta, it's sine A. Okay, now I need to find sine A and cos C. So sine A is nothing but opposite upon hypotenuse. So for A, the opposite is K, right? So I'll get K. The hypotenuse anyway will be always the same, 2K. So my sine A is half friends, okay? Make note of this. Now I need to find cos C. Remember the angle has changed. Don't again find out for cos A, okay? It's cos C, okay? So my angle now has changed over here. So what is cos C? It is adjacent upon hypotenuse, but now my adjacent side is K, see? And my hypotenuse anyway will be the same. Did you observe? Sine A and cos C are the same, right? So that is an interesting observation. Again, let's continue. You have to find cos A also. So cos A, again the same formula, but my angle is now A. So for A, the adjacent is K root 3. The hypotenuse is same. So I'll get root 3 by 2 as cos A. Okay. Then I need to find sine C. So sine C, let me write the definition. Now for C friends, the opposite side is K root 3. Did you see? So I'll write here. The hypotenuse is 2K. So K and K gets cancelled. So see cos A and sine C, did you observe? They are the same. Okay, now let's write what we have to find. We have to find sine A cos C plus cos A sine C. Now very carefully substitute friends. Here's where you need to take care. Don't mix up A and C ratios. So sine A is, I have to take half. Okay. So if you take care of these small things, you will definitely get the correct answer. So cos C is going to be half again plus cos A is square root of 3 by 2 and sine C is also square root of 3 by 2. So this is 2 into 2 is 4. There's a plus sign. Now root 3 into root 3 means the root goes away friends. You'll get 3. 2 into 2 is 4. 1, now the denominator is same. 1 plus 3 is 4. So you will get sine A cos C plus cos A sine C as 1 friends. Okay, I hope you understood. Now the same way you need to do the second part. Now the second part will be easier because I already have all the ratios in hand. So I just need to substitute carefully. Okay. Now cos A. Cos A means, yes, it is square root of 3 by 2. Cos C is half minus what is sine A? It is half into sine C is, yes, square root of 3 by 2. So this is root 3 only. 2 into 2 is 4. Root 3 by 4. And see, have a look at this. They are both same. So when I subtract them, you will get 0. So that is the answer, friends. So this second term is equal to 0. I hope you understood this. Now here is the 10th question. In triangle PQR, right angled at Q, PQ plus QR is 25 cm and PQ is 5 cm. Determine the values of sin P, cos P and tan P. So let's write down what is given to us. So it is given to us that PR plus QR is 25 and PQ is 5 centimeters, friends. Okay. And we have to find sin P, cos P and tan P. Now with what they have given, let's quickly draw the diagram. They have given that the right angle is at Q. So here is my Q. So let me take this as P and this is R. You can take it in any way you want. Now friends, we have to find sin P, cos P and tan P. Now it's only given to us that PQ is 5 centimeter and they have given PR plus QR as 25. They haven't given the individual lengths. So my first job is to find out the remaining two sides. Then only I can find the values of the ratios. So how do I find PR and QR? Well, the only way out is using Pythagoras theorem, friends, because that's the only theorem which connects all the three sides of a triangle. So let's use Pythagoras theorem. Okay. This is my Pythagoras theorem. Now PR square, I don't know, but can I say that if PR plus QR is 25, can I say that PR is 25 minus QR? What did I do? I just brought the QR to the other side. Yes, this is correct. So instead of PR, let me write this as 25 minus QR. Remember friends, this is the whole square, okay? These both terms are getting squared, equal to PQ, yes, I know it as 5. QR square, I don't know. So I just leave it as it is. So the main idea was, friends, that I reduce this equation to one variable only. Now see, the only variable I have here is QR. So it's easy for me to find the value of QR. Now here I apply the identity A minus B the whole square. Do you recall? Let me just write it over here for you. So I just use this identity over here. This is 25 the whole square plus QR square minus 2 into 25, that is 50 QR equal to 25 plus QR square, friends. This is the value. Now 25 the whole square is 625 plus QR square minus 50 QR equal to 25 plus QR square. Be very careful, friends, when you're solving. Now, did you see QR square and here also QR square? So I can easily cancel them both. So what am I left with? 625 minus 50 QR equal to 25. So let me just bring the constants together and the variable on one side. So I'll get 625 minus 25 equal to 50 QR. So this is nothing but 600. Okay. So 600 by 50 equal to QR. So this is 12, right? Okay. So QR is 12 centimeter. That's great. We have found out one of the sides. We have found QR as 12. Now what is remaining is the hypotenuse PR. But I already know that PR plus QR is 25 because it's given to me. So I just substitute 12 over here, the value of QR. So I hope you're getting it, friends. So I'll get PR as 13 centimeter. That's it. All our sides are known to us. Now you just have to use the ratios and find the values. So sin P, remember where is my P? It's over here. So sin P is the opposite side by hypotenuse. What is the opposite over here? Yes, it's going to be 12. The hypotenuse is 13, friends. See, very easy. Now I find out cos P. as adjacent by hypotenuse. This is my P, so my adjacent is this side. See, 5 by 13. Now tan P, again I can use the formula opposite by adjacent. So this is my P, opposite is 12, adjacent is 5. Okay friends, so we have found out all the three ratios. So with this we have finished. So friends, I hope you understood how to solve all these questions. One more thing which I forgot to mention is, just in case you have a doubt, in trigonometry, whenever you write sine square A or cos square A, just remember it is nothing but sine A the whole square or cos A the whole square. Okay, so in those previous questions where we got, sine A as, I'm just taking a value, say 3 by 4, and they're asking for sine square A. Just you have to take it as sine A the whole square. Okay, you just have to go like this. So don't get confused friends, these two terms are one and the same, but commonly they write it as sine square A. They don't write it as sine A the whole square every time. So these two are the same. So that's what I missed mentioning to you in the question. So friends, I hope that this video has been useful to you. If it has been useful, please do like and share the video. Consider subscribing to Enjoy Math, and please leave your comments in the comment section below. So till we meet again in the next video, take care.